Can anyone help me with this rational? I tried solving it by multiplying both the numerator and the denominator by the negative fifth root of 4, but I apparently got a wrong answer. Being stuck on sense, any help would be appreciated. Thanks. Let's go over this. First, whenever we're trying to rationalize the denominator, we don't always multiply the same radical, top and bottom. It depends on the situation. I would like to give you a general review first, and then I'll show you how to work this out. In fact, for this particular question, there's a quick way, thanks to the fifth root of 12 on the top, which matches with this. But anyway, here is a quick review. Have a look right here. First, if the question is 6 over square root of 2, then in this case, yes, you multiply the top and bottom by the same exact radical. Why? Because square root of 2 times square root of 2, we can multiply them, you keep the radical, and then just do 2 times 2, which is 4. And what's square root of 4? It's just a 2, right? Yay. No more square root. So as you can see, on the top we get 6 square root of 2, and then on the bottom we get a regular 2. And then now what? Well, this 6 on the outside and this 2 we can reduce. Notice, here we have 6 times square root of 2 over 2. We can reduce this. If this is a plus or minus, then you have to reduce it carefully. But for this one, 2 goes into 2 one time, 2 goes into 6 3 times. So the final answer is 3 times square root of 2. However, if we have a different radical, let's have a look at 6 over the cube root of 2. Can we just multiply the same thing? Cube root of 2 on the bottom and also on the top. Well, be careful. Cube root of 2 times cube root of 2. When we multiply them, we keep the same cube root. But here, we do 2 times 2 is 4. Now, what's the cube root of 4? In fact, it's an irrational number. We don't know how big it is. So what do we do though? What went wrong with this? The reason that this does not end up nicely is because the number we multiply, it does not produce a perfect cube on the bottom. So let me show you. In order for this to work, we have to remember the perfect cube. Firstly, 1 to the third power is 1. You never use 1 for this situation because it doesn't reduce anything, but it's a good stuff when I introduce. But anyway, 2 to the third power is what? 2 times 2 times 2, which is 8. And then we can continue 3 to the third power, 3 times 3 times 3, 27, and so on. Once you know these numbers, you will know that the cube root of 8 will give you a 2, and then the cube root of 27 will give you a regular 3, yeah? And so on, so on, so on. So you see, when we have 2 times 2 inside, that gives us 4. It's not enough. So, what do we really have to multiply? We have a 2 right here already. How can we produce the 8? We actually need 4, right? Yes. So right here, in fact, we are supposed to multiply cube root of 4, also cube root of 4. That way, cube root of 2 times cube root of 4, we get the cube root, and then 2 times 4, we get the 8 that we want. And this is a nice number. This right here is just a very nice number too. So you see this becomes 6 cube root of 4 over that nice number 2. And then 6 and 2 can be reduced just like that. 2 goes into 2 one time, 2 goes into 6 3 times. So that will give us, this is just a regular 3. This is the cube root, and then we have the 4 right here. Just like that. Now, we have the fifth root of negative 4. So, in order to rationalize that, we have to think about how to produce a perfect fifth power. And let me write that down for you. First, let's begin with 1 to the fifth power. It's just a nice start. Next, 2 to the fifth power. That's 2 times 2 times 2 times 2 times 2. It's 32. And then you see 4. We have 4 right here already. 4 goes into 32 8 times. Yeah? So in fact, we know this is actually enough. But if you want to do the next one, 5 to the 5th power, that would be 243, and then so on, so on, so on, right? All right, here we go. Let's come back here. We do have a negative. Here's the thing. When we have an odd power here, if we have negative 1 to the 5th power, that will also give us a negative result. So when we have a 5th root and then inside is negative, you can put a negative on the outside. So maybe let's take care of that first. We get the 5th root of 12 on the top, over, put the negative out, and then we have this 4 here, and then the 5th root of 4. Yeah. Now, let's see. We have the 8, we need to produce 32, right? So that we can end up with the 5th root of 32, and that will give us just a 2. We need multiply by 5th root of 8 here, and likewise here. Remember, I told you there's a fast way to do it, but let's just go along the way. The fast way is because we have this to help us out, but let's just finish this. This times this is what? It's just 5th root of 32. And that is just a regular 2. So here we have the 5th root of 12 times 5th root of 8. So that's 5th root of what? Multiply the 12 and the 8 together because they're both inside. We get 96 over negative. And then we have 4 and then times this 2. Okay? No. Alright, so let me just continue here. Right here, on the bottom, we get negative 8. But on the top right here, can we break down 96? And one of the numbers shall be this. Yes. I'm going to break this down. 5th root of 32 times the 5th root of 3. Because 32 times 3 is 96. And the reason I did that is because this is a nice number too. So we have regular 2, and then times the 5th root of 3 over negative 8. And let's just reduce this. 2 goes into 2 one time, 2 goes into 8 4 times. So finally, after all that, we get a negative, so let's put a negative here. And then we have the 5th root of 3, and then over 4. The negative on the bottom can be put in the front, or on the top, or keep it on the bottom, but this is usually preferred. So this right here is the answer. I went over all this just because sometimes we may not have the same root on the top, then you really will have to do this, right? But of course, as I said, there's a fast way. So now let me really show you the magic. And here we go. Firstly, we have this over 4 times that. Both of them are inside of the 5th root, right? The 12 and also the negative 4. So let's put down 1 over 4, and then let's just divide the numbers inside first. We get the 5th root. On the top we have 12, on the bottom we have negative 4. This is actually allowed, right? And then have a look. 4 and 12. 4 goes into 4 one time, 4 goes into 12 3 times. So the inside is a negative 3. Negative can be put on the outside, so this right here equals this negative out. And then let's put the 5th root of 3 on the top, and then over the 4. That's it.